Hello, today we are going one step further than we did yesterday. Yesterday we factored, today we're factoring and solving. Before we get to the actual solving, I want to talk a little bit about what we call solutions to quadratic equations. The solutions of a quadratic equation can be called roots or zeros. Zeros of a quadratic equation are when we get real solutions. The zeros are when we have a parabola on the graph and it's where it crosses the x-axis. We're going to talk a little bit more about this as we do more problem solving with quadratic equations in this unit. For right now, let's go ahead and get started with our solve by factoring. First problem is easy AC factoring. I recognize it because there are three terms and the x squared term leads with a 1. So we're going to say what multiplies to give us 2 and adds to give us 3. That would just be 2 and 1. We go ahead and put those in parentheses, x plus 2, x plus 1 equals 0. And then we are going to set each parenthesis equal to 0. You can go ahead and write these separately, but I can see if I just subtract 2 from both sides, I'm going to get negative 2. If I subtract 1 from both sides, I'm going to get negative 1. So the solutions to this quadratic equation are negative 2 and negative 1. Now number 2, I don't even have it equal to 0 yet, so I need to subtract 8x on both sides and get it in proper descending order before I factor. So I get 5x squared minus 8x plus 3 equals 0. Now I have the rainbow method, or the more difficult AC factoring, because my x squared term leads with a number greater than 1. So I'm going to multiply 5 times 3, I get 15. I'm going to find what multiplies to give me a positive 15, but adds to give me a negative 8. That would be negative 3 and negative 5. So I'm going to replace my middle term with these new terms. Now I'm going to factor by grouping. I'm going to look and see what's the greatest common factor I could divide out of these two terms. That would be an x. I'm going to look and see what's the greatest common factor I could take out of these two terms. The only thing I can take out is a negative 1. I want to make sure I take out a negative. Remember I said if it leads with a negative, factor out a negative. If you don't, you are not going to get like parentheses. You would have gotten the opposite, and then we wouldn't be able to go any further. Now that my parentheses are the same, I'm going to factor those out, and I'm going to put my leftovers in another parenthesis. And I'm not done. I need to set each parenthesis equal to 0. Some of you may need to actually write the work. You may actually need to look at this. 5x minus 3 equals 0. I'm going to put the work up here to show you. And you may need to go ahead and solve for x. Add 3 to both sides. Divide both sides by 5. So you get x to be 3/5. So I get 3/5 for one answer and positive 1 for the other. I'm going to go ahead and erase this and do my last problem. Okay, again, I have more difficult AC factoring. However, you should recognize that there's a perfect square here and a perfect square here. So when we factor, this is called a perfect square trinomial. We're going to take the square root of 4x squared, which is 2x. We're going to write it 2 times. We're going to take the square root of 25, which is 5. We're going to look at the sign that is this in the center, and we are going to put that for both of our signs. Now another way to write this, you can write it separately, or you can write it as 2x minus 5 squared. Either one is correct. We still want to set the parenthesis or the factor equal to 0. When we do that, we get x equals 5/2. You don't need to write it twice. It's the same answer no matter which parenthesis we set equal to 0. Okay? I'd like you to pause the video and I would like you to try number 1 on your own. This is the more difficult AC factoring because it leads with a 2, so you're going to have to do the method we did for my number 2 up here. Okay, sometimes you're going to see it worded like this. Find the zeros of a function. This time it's not equal to 0. There's a y, there's an fx, and there's a y. That's because we're asking to imagine if we put these on a graph, where would the x-intercepts be? So I'm going to go ahead and solve this, and we'll talk about our answers as we do it. This is more difficult AC factoring. We're going to multiply those two together. We get negative 12. What multiplies to give me negative 12 and adds to give me positive 11 would be 12 and negative 1. I'm going to go ahead and rewrite this. I'm going to factor by grouping, take a 3x out, I'm going to factor these out. I'm going to set each parenthesis equal to 0, and when I do that, I get -4 and +1/3. Okay, let's go ahead and do another problem. Now, we're still going to assume we're setting this equal to 0. We're going to go ahead and take out a GCF. I can take a 2 out of this one, which is going to help me because now I'm able to do the easier AC factoring. I can do what multiplies to give me -12 and adds to give me -4. That would be -6 and 2. Put those in parentheses. When you do that, you set each parenthesis equal to 0. All right, I keep saying parenthesis, but we're really setting each factor to 0. If this was an x, I would also be setting that equal to 0. But when I set 2 equal to 0, it doesn't make sense, it doesn't work, there's no solving. So here I get 6 and -2. Okay, let's take a look at the last problem. There is a GCF here. I'm going to take out an x. When I do that, I have 9x squared minus 4. This is difference of perfect squares. So we're going to square root each of those. Put 1 with a plus parenthesis and 1 with a minus. Now, here's a perfect example of what I was talking about here. I don't have a number outside of the parentheses. I actually have an x. You are going to set that equal to 0. We are going to get 3 different answers here. We're going to get x equals 0, +2/3, and -2/3. Now, I do want you to make sure you pause the video, try the second you try on your own. If you have any questions, comments, or concerns, go ahead, write it at the bottom of the paper, and I will see you tomorrow in class.